Okay, this lesson is on understanding domain and range. We're going to break this into two parts. This first part, part A, is going to cover domain and range when we're talking about discrete data. Okay, so it's important to understand discrete versus continuous. And I don't want this video to get too long, so we're going to break it into the two parts for discrete and continuous. But let's start out with some background. The definition of domain is the defined or naturally unrestricted set of values allowable for the independent variable, which is commonly the x variable or the variable on the x-axis in an algebraic relation. Okay, when I say defined, quite often we define the variable, its value set based on just practical reasons. For example, if I'm measuring motion versus time, I usually don't go back in time, so I might restrict the domain for time to those times that are greater than 0. Okay, and that just makes it easier to understand the data and also to graph it. So that would be a case of defined data. Or naturally unrestricted means that if I did not have to restrict the data and I were putting this on a piece of graph paper, how far could the values go with nothing else to restrict the data? And that will be applying more to the continuous data, and we'll of course illustrate that in part 2. The range is the defined or naturally unrestricted set of values allowable for the dependent variable, which is, most commonly with algebra, is the y variable or the variable which is attached to the y-axis, again in an algebraic relation. Okay, so let's go here and notice that a part of understanding domain and range is getting a grip on how these terms apply to discrete and continuous data or relations. Now, first of all, discrete data indicates individual XY pairs of data like you would get if you were measuring or collecting information in a table, such as the position of a ball rolling down a ramp at 5-second intervals. You would collect the distance and you would collect the time and make those into a relationship of time versus distance. In this case, the domain and range are defined or restricted to the specific measurements that you made. Another example might be, for example, annual population of the city of Chattanooga. Each year you would measure that population, and that would be a discrete data point. So there's all kinds of cases, particularly in experimental things, where we use discrete data. Now you're going to find later on in algebra that discrete data may actually be used to predict an equation, which is what we call continuous. Okay, but I want to just plant that seed in your mind and go from there. Okay, so let's look at domain and range for some discrete data. And the data I'm going to show you is really not specific to anything, just made up some XY pairs. It says consider the set of XY pairs, and we're going to plot those in a moment. But look at the pairs. These are XY pairs: 3, 7, 4, 1, 5, 5, 7, 2, minus 2 and 4, 2 and minus 3. Okay. Now the domain of this set would be, we can use red, what the heck, right? So there's the domain. The domain would be the set of values that defines the x's. Okay, so 3, 4, 5, 7, minus 2, and 2. Okay, there's no repeats here. Okay, and then the range would be the y values: 7, 1, 5, 2, 4, and minus 3. Now, this is just a listing of the numbers. The proper notation with domain and range is to list the data in the order numerically that it occurs. Numerically, not sequentially. So the proper way to list the domain then, mathematically, and I'll take it down here, the domain should actually be listed as, and we look for the smallest value first, 9, minus 2, and then the next one is 2, and then 3, and then 4, and then 5, and then 7. Okay, so that's the proper way to do that. And what we quite often do is we put these in a table, which I'll do for you in a second. The proper way to look at the range is to do the same thing. It's going to be -3, and then 1, and then 2, and then 4, and then 5, and then 7. Okay? Now, I want you to notice something extremely important here, that a listing of the domain and range values has nothing to do with the relationship between them, because when we list them in numerical order like we did in the green here, you will see that the values of x and y pairs do not line up with each other. Okay, so what we do is we create what's called a domain and range map. Okay, map. And so what this map looks like is we're going to take the x values and do it in a pattern like this. Okay, and by the way, on domain and range we do not repeat values. So I didn't do it for this particular case, but we will here in a moment. We'll put up a different case to show you what we're talking about. Is that if there's a repeated value in the domain or range, we do not list it twice, okay? Because the domain and range is specifically the set of values involved, not how many times they occur. Okay, so but let's go ahead and do this one. So let's do -2, and 2, and 3, and 4, and 5, and 7. And then over here we got -3, and 1, and 2, and 4, and 5, and 7. Not much variety here, right? Okay, now how do we connect these, right? Okay, well what we do is we use connecting lines to connect the values with their matching x and y's in this domain and range map, okay? So we had, let me scroll back up just a second so we see our pairs. So 3, 7, okay, what we would do is we would connect the x3 with the 7, okay? Then we would connect the 4 with the 1, and then we would connect the 5 with the 5, and then we would connect the 7 with the 2, and then we'll connect the -2 with the 4, and we will connect the +2 with the -3, like that. And that gives us, this is our domain, and this is our range, and that's a domain range map. Okay, so it lists, notice that it lists the values in numerical order, but then connects those values with the correct pair. Okay, so what would this look like on a graph? Okay, 3, 7, we would go over 3, 1, 2, 3, and up to 7. Okay, there's 3, 7. 4, 1 would be 4, 1 would be right there. 5, 5 would be right there. 5, 5, and then 7, 2. 1, 7. There's 2, and -2, 4. So -2 and 4 would be right here, and 2 and -3. 1, 2, and -3 would be right here, right? And that's what that would look like. Now, I want you to understand something about discrete data. Unless you're told to do so by the context of the problem, there is no obligation whatsoever to try to connect the dots, okay? They are discrete points. They have meaning as discrete points, and so we leave them as discrete points unless we're told to try to, for example, fit a line to that. Okay, this is not kindergarten where your exercise is always to find a way to connect the dots. In a discrete function or discrete relation, we just leave the dots as they are, and we just plot them. Okay, so that's a case one. Let's look at another case. We'll make up one here where there is some repetition in the values, and we'll look at what that does to the domain and range. Okay, so this is discrete data number 2. Okay, we'll just make up some stuff. -4, 3, 2 minus 7, and let's see, 5 again, we'll use that again, 3, 5, let's do 2 minus 1 and 5, 6, okay? All right, now let's do this again. Let's do it with the domain and range. First of all, let's just separate the two lists. The domain list is minus 4, 2, 5, 3, 2, 5, okay? And then the range list, and remember this is not properly done mathematically yet. So the range list is going to be just listing the values. So 3 minus 7, 5, 5, and 2. Oops, I'm sorry. Be minus 1. I was looking at the wrong one. Back up here a little bit. Okay. 5, minus 1, and 6. Okay. Now let's put those in a map. Okay. Domain and range. Okay, so now looking at our list, we're going to put these in numerical order, and we have a minus 4, and we have a 2, and we have a 5, and let's see, we have a 3, right? And we have 5, then we have another 2, but we've already listed 2, right? So in this case, since we've already listed 2, we don't need to list it again, and we don't need to list the 5 again, okay? Same thing for range. Now we have minus 7, and we have minus 1, and we have 3, and then we have 5, and then we have another 5, but we don't have to list that because we already have it, and 6. Okay? So in this case, we don't list the 5 twice, we only list it once, and now this is the domain and range map. Okay. Now, if we wanted to link these up, we can do the same thing we did before, and we'll use a different color here. Let's use green, and let's see, we have minus 4 and 3, and then we have 2 and minus 7, and we have 5, 5, and then we have 3, 5, and then we have 2 minus 1, and we have 5, 6. Okay, so that's what the domain and range map would look like for this discrete data. Okay, and if we plotted that again, we'd get a XY plot. All right, so that concludes part A, where we talk about domain and range of a discrete thing. Remember that the domain and range map does not, until you put those connecting lines in there, does not indicate anything about the linkage between the values. It merely lists the values in numerical order. Okay, and we'll be back with part B on another lesson.